Hello everyone, in this video we're going to cover AND gates. Now, similar to our previous videos, if you've watched on our gates, we've covered a general overview of what gates are and how they work and why we need them and how they can be used. And then we moved on to learning about our NOT gate, and our NOT gate is our simplest form of gate. Whatever input it gets, it'll give us the opposite as our output. Then we moved on to OR gates, and with OR gates they were a little bit more complex than NOT gates because they could take in more than one input, so they could take in two inputs or more. Now with AND gates this is similar, so with an AND gate we can take in two inputs or we can take in three inputs or more. The only difference between an OR gate and a NOT gate is our truth table. So when we've got our inputs here, so our inputs could be 0, 0 or 1, 0 or 0, 1 or 1, 1. This is our input. When these inputs get pushed into our AND gate, the processing that our AND gate does will be slightly different than our OR gate, and therefore it'll give us a slightly different output. So if we go and jump into this, we can see that we will only get a true value, so we will only get 1 as our output if both of the inputs are true. So if 1, 1, we can see these are both true, so this will result in a 1 or a true value as an output. Now with these other inputs here, they're not both 1. So if it's any of the rest of them, unfortunately we'll get a false value, or as we represent it in binary, as 0. So if we go through our truth table here, we can see that 0, 0, again, both of these are 0. In an AND gate, we need both of them to be true. So we need both of them to be 1. So the result of this will be 0. So we can fill in 0 here. Then moving on to the next example, 1, 0, again, they're not both 1, so this would be 0. Then moving on to the next one, again, they're not both 1. So it will be 0, and then finally our inputs 1, 1 will give us a result of 1. And this is our truth table completed for an AND gate. Now I want you to keep in mind, if there was more than two inputs, so imagine there was 3 inputs, imagine we had another input here which was C, so then we would have a totally different truth table. It would be quite a similar result, so only the values of A, B and C that were all 1 would give a true or 1 value as the result, and all the other values would be 0. So if we go and take a binary example that we can use our AND gate in, would be something like, if we picked a number, again we'll go with 5, similar to our OR, and we know that 5 in binary is represented as 1, 0, 1, and we'll pick 1 in this example, same as our last example, and we know 1 is represented by 0, 0, 0, 1. Now if you remember in our last video, when we computed this using an OR gate, we got our result as 5. Now you'll notice when we use an AND gate, we're going to get a slightly different result. So again, we're going to look at these two values here in this column, and we can see 1 and 1 will give us an output of 1, and we can see 0 and 0 will give us an output of 0. Now we can see in this we have a 1 and we have a 0. Now in our OR gate, all we needed was one of our values to be 1 to be able to bring down a 1 here to create our new binary number. Now unfortunately with an AND gate, again, both of the values have to be 1, so in this case this would be 0. So that's one difference between our OR gate and our AND gate. And then similar here, we have 2 zeros, so this will also be 0. And we can see this answer here is 1.